Okay, we are up to 225, last lesson of Unit 2. Let's do this. Horizontal shrink and stretch, which has everything to do with the letter B. And the reason is the period, you can see of cosine, is 2 pi. From here, it's like a bell. And then here's another, it would keep going. Every 2 pi, it would repeat itself. Same thing with sine. You can see from here to here. That's a nice picture. Now I could have picked this and saw that as one cycle, but I like a little bit to the left of the y, a little bit to the right of the y. It just helps me compress and stretch. So you'll see what I mean in a minute. Something interesting about this period formula. Notice it gives you in the formula the normal period. So you can see our A is 1, meaning our amplitude is 1, 1, 1, 1. But also our B is 1. So if we put that in the formula, we go, oh, that's 2 pi, which makes sense, because it is 2 pi. So now they're going to mess with this a bit and see if you can make the adjustments. So you notice we got a whole number here, it's a 2. So that's my B. Now the absolute value is just there, just in case it's negative, which isn't going to happen very often because that would reflect it over the y-axis, which is a little challenging, especially when you start moving these things all over the place. So just know that that's not going to happen very often. So let's do the math. 2 pi divided by 2 is pi. What does that mean? Well, if you use some common sense, the original has pi on this side, pi on that side, so half of our normal period is pi, half of it is pi, adds up to 2 pi. So these walls have to close in this way and this way. So this, I'm going to just get rid of this portion so I don't confuse you. This little curve needs to be horizontally compressed. That's what a whole number is going to do, because you're going to divide by a whole number. It's going to get compressed. It's going to get shrunk. So this wall has to come into here. I'm going to make this right here. This wall has to come in here, and here's where it might be slightly confusing. I'm going to get rid of the original wall just to avoid your brain trying to take in too much. This portion of the graph needs to be squeezed into these walls. So, you see that little loop-de-loop, that valley? That has to happen between here and here. So I'm going to make it happen. This little hill needs to happen, same thing, in between here. So here and here, and there it is. So the original sine wave was compressed by a factor of 2. It was shrunk by a factor of 2, horizontally. We're not talking vertical here. Okay, let's move to this one. We have a fraction. Well, if I said, okay, we got to put the fraction in there, what do you do when you divide by a fraction? You multiply by the reciprocal, which is now 4 pi. Notice it's kind of ironic. We're dividing by a fraction, but this gets bigger. That means it's going to be horizontally stretched. Now I'm going to do the same thing here. Get rid of these the portion of cosine we don't need to concentrate on. This wall needs to move to here, 2 pi. This wall needs to move to here. So I'm going to draw them in, get rid of the original wall, draw it in. Notice from 2 pi to 2 pi gives me my 4 pi, my walls. This bell needs to happen in this space. So, look at some points here. This needs to slide all the way over here. Notice the old wall was here. I erased it, but it was right here. This little spot where it crosses the x-axis is halfway. So what's halfway here? Right there. So I know it goes like this and like that. Same thing happens over here. This little point right here is halfway. So I know halfway of this is right here. This point needs to slide here, and then there it is. So the original cosine, one cycle, one period, gets horizontally stretched by a factor of 2 if you need to talk about it. Okay, that's a good little lesson right there, but there's more coming. All right, so here's a little tricky one. And pre-calc book, they're just throwing a little curveball at you, and you just have to know there's some weird things that happen. And let's just dive in. So let's forget about this for a second. Well, let's not forget about it. Notice I said it's weird. 1, 2, 3, 4. Well, why isn't this pi over 2 pi, 3 pi over 2, 2 pi? And the same thing over here. Let me talk about this first. Notice in my previous two examples, that was like a 2 or a 1/2. Those are numbers. And so then when we put this in here, we end up getting something pi. And that's why our x-axis is in terms of pi. Now, the reason these are numbers is going to happen when we just follow this rule. So we put the absolute value of b. b is pi over 4, which is 2 pi over 1, essentially. Well, it's just 2 pi times the reciprocal of this, 4 over pi. So these would cancel, so I end up with 8. So what that's saying is it's going to take 8 units. Notice the pi's just disappear, and that's why we have to convert the x-axis. You only have one problem like this on your homework, but it's tricky, so I thought I'd show it to you. So now, as we can see, this one repeats itself. The period is 4. I need to take, this is one cycle, right here and here. So now I need to double that, so the walls need to go out here into here, and this needs to repeat itself. So let's take this bowl, this little valley, repeat it from here to here. Well, this low point is halfway of the original wall. Halfway this time would be here. So it needs to go like this. This hill, the halfway point is the peak. So the halfway point here is here. So it just gets horizontally stretched. That's a weird one, and there's no doubt about it. All right, continuing on, we have this new thing called composite functions and inverse functions. So let's start right here. Here's y equals mx plus b. It's a line. Y equals 2x plus 3. I'll just show you one. If I put negative 3 in here, negative 3 times 2 is negative 6, plus 3 is negative 3. And I just did that for all these points. And I only graphed 4 of these points. This one, this one, this one, and this one. And I'm like, okay, I got the idea. There it is. Now what is this thing called inverse function? That does not mean reciprocal. It means, take the original. Remember, this is y equals, and we're going to flip the x's and the y's. So, we're literally going to go like this. X equals 2y plus 3. Then we're going to solve for y again. So we're going to subtract 3, subtract 3. I'm going to flip it. 2y equals x minus 3. I'm going to multiply by a half, and I get y equals 1/2 x minus 3. Now, if I graphed this, you're going to notice I'm going to use the old school technique. My y-intercept is negative 3. And now I'm going to go up 1, right 2. Up 1, and right 2. All right. Yeah, oh boy. Let me pause this a second. Okay, so what I did, I made a big mistake in this lesson. You see these little units are real tight, and these are really long. It's going to distort this drawing really bad, so I'm going to explain it different. Remember, the first thing we did was we switched our x's and our y's. So forget about this explanation. We're going to go to this chart, and we're going to follow that direction. We're going to switch our x's and y's. So the first one doesn't even change. The second one is -1, -2. The third one is 1, -1, and then 3, 0. Now if we plot those, 3, 0, 1, -1, -1, -2, and then -3, -3. Notice they match a point. The original drawing wasn't going to do that. So, no, my drawing's not perfect this time either, but I want you to notice something. This is huge. If I take this line right here, it's got a name, y equals x. The inverse function will always be a mirror image spun 180 over the y equals x line, and it just happens. So if they gave you a math problem like this, and they said, okay, they don't even give you this, and they don't give you this, they don't give you the equation, they just give you a drawing, and they say, hey, find the inverse function's graph. You would just take the y equals x rule and flip it. So this would flip over, going there. This would flip over, going there. Now, just to prove that this works, I'm going to take this function. I'm going to put in, well, let's see here. I'm going to leave it right there. So I'm going to talk myself into confusion and confuse you in the meantime. All right, part of math is just owning your mistakes. You guys probably saw it. But if I multiply that by a half, that by a half, that by a half, I screwed up right here, and that should have been minus 3 halves. And I wanted to show you that if I just plugged in like this point, x is 3, 1/2 times 3 minus 3 halves, I should get 0, and I do. So there, I screwed up, I confused myself, but it's part of math. The last thing is, I forgot to say this. Because we flipped the x's and the y's, it doesn't any longer equal y, it equals the inverse function symbol. That means you took the original, flipped the x's and the y's, and you solved for y, and you got the inverse function. Okay, there you go. I hope that makes sense. All right, so now we're going to apply some of what we learned in a different way. They say, find this if f of x equals this, and g of x equals this. You see, they don't give you an equation, so it's a little like, whoa, what are they trying to do here? Well, g of negative 3 is just saying, what does y equal when x, what does g of x equal when x is 3? Well, it's negative 4. So you can really ignore all of this at the beginning, and you just say, aha, that stuff in there equals negative 4. Now I got to find the inverse function when x is negative 4, which means I take this, I realize that it equals this. I'm going to make a little line here because here comes the inverse function where I flip the x and the y. So x equals negative 2y minus 4. Add 4 to both sides and flip it. And now I'm going to multiply by negative 1/2. So I get y equals negative 1/2 x minus 2. And what this is saying is plug this in for x into this, which remember, because I flipped the x's and the y's, it's now equal to this, which means plug negative 4 in for x, so negative 1/2 times negative 4 minus 2. That's 2 minus 2, which is 0. So this whole original thing equals 0. All right, one more for you, and then we'll be done. All right, last little challenge. So now, same information, but they give us this. So the first thing they want us to find is this, which means you don't go to this, you go to the inverse function, which is right here. Plug in x is 4, so we get negative 1/2 times 4 minus 2. That's negative 2 minus 2, which is negative 4. So we take this out, and we say negative 4. Now here comes the twist. Notice this was g of x, and now I've got the inverse function. What did I do to all these? I flipped them. So this is saying, if x is negative 4, what's the inverse function now? Well, here's negative 4. It corresponds to the inverse function, which is negative 3. So negative 3 is my final answer for that crazy original looking problem. Not bad after you practice some. That's it.